Bonjour à tous, je suis Nayat Sanchez Pi, la nouvelle directrice d'Inria Chile il y a quelques mois. Inria Chile a été pilotée par Claude Puech, qui est là-bas. Ça va? Et j'ai remercié les organisateurs pour l'invitation qui me permettra d'expliquer comment les uniques caractérisations d'un pays comme Chili permettent d'amplifier la collaboration entre chercheurs d'Inria et Chili, et c'est lui qui permet d'amplifier aussi l'impact de la recherche dans les sciences d'Inria. J'ai commencé par m'excuser parce que je ferai la présentation en anglais. Mon français n'est pas très fluent en ce moment. Et deuxième, parce que je dois parler très rapide, parce que je entraîne que... So, I will switch to English if you don't mind. This is actually a very interesting track that has been discussed in already 2 sessions, and in which I will talk about how different calculation tools can be applied in the field of renewable energies, and how the work we do in Inria Chile in collaboration with Inria research teams and Chilean collaborators. I also want to introduce complementary topic on how to make computer science even greener. So I think that the best way to to understand Inria Chile is to start by understanding Chile itself and the characteristics of Chile. So as you may know, Inria, Chile, but the thing is that it has a particular geography, extending itself from north to south. And the map projections that are commonly used to create world maps undermine our understanding of the vastness of the country. Because, for example, if we put the bottom part of Chile in Malaga, for example, in Spain, and the top part of it reaches to the north part of the Scandinavian peninsula. And if we put one top in New York, the other one reaches San Francisco. So it seems that is something clear, but from the maps that we are used to use are don't. Well, Chile has also a sustained economic growth for the last 20 years, and this is important because it has also seen a progressive but important improvement also in social indicators. It is probably the most institutionally stable country in Latin America. The economy is stable and are growing. There are a lot of growing efforts to decarbonize its economy, maintaining the phasing out of coal-fired power stations and encouraging the development of renewable energies and sustainable mobility. In fact, the president of Chile announced last Tuesday, that they will be closing 5 of the plants, and for 2040 they will be all closed. So the Chilean economy has always depended also of natural resources. Mining, for instance, has a key role. Chile is the first producer of copper in the world. It hosts also 47% of the known lithium reserves in the world, which is huge. And however, on the other hand, it lacks of deposit of fossil fuels. So, for example, in this figure here, you can see how the export products in Chile are distributed, and we can verify that the dependency of Chilean economy on mining, and particularly on copper, is very high. So another important characteristic of the country relies on its own shape, as I already told, and it is very long and narrow country, and it means that it's a sort of logistical nightmare if you need to move things or materials around Chile. So they have drastically also different climates, from the Atacama Desert to typical subtropical forest, or even to the glaciers of Antarctica. And these diverse landscapes are in these landscapes are many communities that live semi-isolation. So this is also another thing important. And even another thing is that even if there are big mountains, there are not enough rivers. So there's no big rivers to produce electricity. So this is an issue, okay? It's a nice picture of Antarctica. So it must be mentioned, however, that there has been an intense also investment from the Chilean government on infrastructure for connecting different parts of the country. Even if sometimes there's new highways that don't look extremely inviting for drive, but there's an investment there, okay? And Chile is also known for the catastrophes. You all know that. There's earthquakes, tsunamis, volcanoes, and if it was not enough, there is an issue with fast flooding. It has never rained in Chile. The overall infrastructure and also the nature itself is not prepared for it. This is an issue. And it has to do with the fact that there are no rivers and no natural paths for this rainwater to flow. So this is an issue. And these events are relatively frequent, and the country has learned to live with them. So for you to have an idea, when I got to Chile, I installed an application on my phone, which is supposed to alert when an earthquake happens. And I ended up on installing it because it was very hard to sleep with so much alerts per day. So we have a lot of earthquakes every day. So another characteristic of Chile is the Atacama Desert. Has the highest level of solar irradiance on Earth. And this is due to the same reasons that make it great, for example, for astronomy, because it has fewest numbers of cloudy days in the world. So this is another characteristic. But as we say in computer science, this cannot be seen as a bug. We can see this as a feature for research, for example. And of these characteristics, among others, of course, makes Chile a very special country in Latin America and the world, and a great candidate to switch to green energies. For instance, the desert areas that we have just saw, that receive the largest solar radiation in the world, has also low land cost. So this is good. Those clear sky, for example, have attracted astronomic centers of the entire world, and mining also takes place there in this area, in the desert, in the Atacama Desert. So it represents a close match between green energy, for example, and industry. Also, the long shorelines and direct ocean exposure makes very interesting for the development of tidal and other forms of marine energies, in particular to cater for isolated communities. And we also, I will talk about this, but we have a project on that. And finally, the relatively high frequency of these dramatic events have become a state issue where all the governments, and also at all levels, and even the citizens, understand that having redundant resources of energy is a necessity to guarantee the capacity of communities to respond when these events hit the country, okay? So, well, I already mentioned the importance of astronomy in Chile and for Chile. In fact, currently 70% of all the telescope and radio telescopes observation are made in Chile, and 98% of the south hemisphere's observations come from there. So, as you can imagine, astronomy is more and more a computational science. As an astronomer, a friend of mine said, they no longer do observations on a telescope. They analyze tons of data that had been gathered before. So that's a fact. And there are different astronomical challenges that push also computer science forward. You can imagine how to move, for example, 1 petabyte of information every night from the middle of the desert to the analysis facilities, and also how to process and mine the relevant features. This is also an issue. Without mentioning, of course, the complexity of the operations that are essentially, in these cases, and these observatories are remotely operated. Just to give you an idea, every day, the square kilometer array telescope will produce 6.5 exabytes of information, data. And here we can compare in this figure the amount of information that Facebook produced, which is 180 petabytes, Google with 98 petabytes, or YouTube, okay, just to have you an idea. But please bear in mind that this is just a reference because the square kilometer array is not in Chile, it's part in Australia and part in South Africa, okay? But just to have an idea of how's the amount of data that is the astronomy observations that are produced. Another characteristic that push a lot of computer science forward is the characteristic of the diversity of the signals captured. While there are many telescopes, for example, that collect visible and infrared lights, other important groups is focused on radio signals, and only one is able to sense gamma rays. So because of all these investments and collaborations, astronomy, for example, and astrophysics are the leader areas in scientific research in Chile. So, and this picture that is updated is from 2018. So, you can see that by far, astronomy and astrophysics is the area with more production, scientific production. In Chile, as you know, Inria is in Chile since 2012, as a catalyzer of research and innovation. Inria in Chile is focused on 5 priority research and development lines, but they are all very mapped with the 8 scientific lines of Inria: artificial intelligence, data security and privacy, modeling, simulation, optimization, human-computer interaction, visualization, system, networks, and IoT. And as you know, the new plans for Inria Chile is to fully insert Inria Chile into Inria Actions. You may have read that. Bruno mentioned that recently, even for a second time in the COP document. So we are committed with scientific excellence, and we will do that in a model of articulation of Inria researchers with local research partners, and foster and affirm Inria as a global brand, not only in Chile, but also in South America. We're also committed with a problem that is not only in Chile, not only in South America, it's everywhere, that's with the talent creation. And this is an objective that we will focus on. So we are implementing a tech training center for professional training, focus on deep tech, and open source software of Inria, so we can have a direct impact into industry, for example, using their own data. And we're also building a startup tech studio to foster the creation of technological-based startups, but also to be a soft landing platform for French startups, hopefully for Inria startups that would like to come to Chile or even as a bridge to South America. And we have, as you know, partnerships with the main universities in Chile, already in fact 8, but we have relationships and coordination with more than that. And it must be underscored the strong academic connections between Chile and France, which had an important consolidation when political reality in Chile made a lot of its scientists and academics to immigrate, and France, a lot of them came to France to study the PhD and all that. On our side, Inria is also very active, surprisingly for me, this number, because it's almost 1/3 of the Inria teams has some sort of formal collaboration with Chile, which is very good. And it means that it's a good value, okay, in terms of research there. And it's our task in Inria Chile to articulate, enhance, and also consolidate these collaborations. In case of green energies and resilience, Inria Chile has stepped into green energy domain, established research projects that involve Inria researchers, also researchers from local universities and French and European industry partners like Naval Group or Enel Green Power. On this direction, we have focused on the modeling and forecasting of turbulent ocean flows and their application to tidal energy consumption and generation, the high-resolution modeling of ocean wind maps, the pollution impact of other dispersing industries, for example, that this is an issue, a very local issue in Chile, and the simulation and impact of tsunamis, for example, in the coastal areas. This is a very good example, for example, of how we articulate this. And since 2014, we have a consolidated collaboration in this area, and with Inria researchers, also Inria Chile and local universities are addressing different challenges relating to marine energies. And I want to acknowledge Antoine Rousseau, that I know that is somewhere. I don't know. Hi. So another project we're starting to unfold has to do with the impact on wind and solar energy generation. Well, you know that solar panel generation efficiency depends on the temperature of the panel. The colder the panel are, the more efficient it is at energy generation. It is a contradiction because the sun generates heat, but remember the desert is there. So the same plant installed in the same area can have up to 20% difference in generation just because of the difference of wind incidence. So modeling and predicting wind is essential, for example, for placing and operating the plant. And we are prospecting together with local university in Chile, in particular with Universidad de Antofagasta, and of course with Inria researchers of its impact, if it can be modeled in order to choose the correct plant location or automatic reorientation of the panels to dissipate the maximum amount of heat. So we are also prospecting another project together with Anna Busy, that we have already talked, hi, who had just talked, and in the area of smart grids and in terms of this, wow, 1 minute. Okay, but we have understood that we need the state-of-the-art computational tools to tackle the challenges involving the operation green energy consumption and generation. But what about the impact of computing itself? We have been discussing during this morning and also last Wednesday about many approaches improving the generation, transmission, layouts, and all that. And I think that if we're going to really tackle the CO2 emissions problem, we need to think also in our own impact. And when I say that, I look to the deep learning guys. So far, we have understood that to turn viable an environment-conscious strategy, we need to extensive use the computer science. And in particular, areas like high-performance computing, artificial intelligence, machine learning, simulation modeling. And what we need is to understand how our own tools impact the environment. And guess what? To overcome this problem, we will probably need to use the same tools, okay? On one hand, it has been estimated that the energy demands on digital economy will account from between 20 to 50% of the global electricity use. And the graphical processing units are mostly to blame on this. And for example, this is a recent analysis, even if I'm not fully happy on it, it can be verified, how, for example, all the search and tuning required for training a transformer network produce the same amount of CO2 has 3 average cars in their lifetime. So this is huge, this number is huge. So in order to tackle this problem, we will need a holistic approach, and probably starting at the hardware level, we need to think the hardware substratus, and here is unlikely what we would get rid of the GPUs at training time, but at use time there are alternatives like, for example, FPGAs or others. And similarly, we could use, for example, low precision computing to areas where energies can be obtained from renewable sources, and even to move around the planet adapting to the availability of energy could be an option. And then we need to extend the use of optimization methods, like evolutionary computations and others approaches, that can be applied to narrow the search process of the hyperparameters to areas of high potential. So, and last, and certainly not least, we must further study how to reuse trained models and perform transfer learning on them. And it is to fine-tune pre-trained models to solve a different problem than the one that was originally created. And just 1 second. At this point, in my opinion, it is essential to start to address our project under an environment-conscious point of view. And in this regard, we plan to start to find chances for piloting technologies, and astronomy-related problems are perfect pilots in this case because they pose a big challenge, both scientifically and also technologically. And also a lot of data-intensive processes are inside. So we have added an energy consciousness has another objective. And besides waiting to train optimal models, we want their training process to be as energy efficient as possible.